Okay, let's look at homework, what it labeled in the syllabus and Zone D2L is homework 2 and homework 3. Homework 2 comes from Whit and Whit book, problem 7.6, which is on page 169. So what we're going to do to solve this has to do with, I'm going to open up an SPSS document and start a new one. So there's the blank SPSS document. So we're looking at the number of drivers in a household and the number of cars that are in their yard. And we're seeing how we would predict if you have a certain number of drivers, how we could predict how many cars you probably have. And I ask you to do just A and D from that. So, well, first of all, let's enter the data. So we go to variable view. Our two variables are just simply drivers and cars. So I'm going to type in drivers. And then underneath it, I'm going to type in cars. Again, the default options will pop up for the rest of the row. So drivers and cars. Again, make sure you click off the cell before you click on the other view, so it shows you everything. So when I go to data view, these are going to become column headings, and there they are. And I'm just going to put the data in exactly like it looks from the textbook. So the number of drivers, respectively, are 5, 5, 2, 2, 3, 1, 2. And the number of cars, respectively, 4, 3, 2, 2, 2, 1, 2. And again, these data have to be paired together, right? Because this one household has 5 drivers and 4 cars. That's the same household. It's the same place. So they've got to be paired just right. So let me go ahead, even though it asks for a scatter plot, first of all, let's go ahead and run the analysis, and then we'll get to scatter plot. So I'm going to go to regression, linear regression. My dependent variable, the thing that we're trying to predict, is cars. That's going to be based on the independent variable, or the predictor, which is drivers. And all I need to do from here, if I look at all these other things like statistics, I don't think I need any of this stuff for the simple regression, because we have only one predictor, so it's simple regression, not multiple regression, as we'll see the other problem is. So if I click OK, I'm going to get my output window. And what's going to help me predict is going to be these two numbers right here. Very last little table it gives you, the first column under unstandardized coefficients. So we'll come back to that in a minute to make our prediction. Let's go ahead and do the scatter plot. So if I do the scatter plot, I want to go to graphs, legacy dialogues, and it's going to be a scatter plot. And I want this to be a simple scatter plot. We need to go to define. Everybody up with me? And all I'm going to fill in is the X and the Y axis. Again, the X axis is typically the predictor, the independent variable. The Y axis is the outcome, the dependent variable, which is cars. So again, independent, the predictor is drivers and cars. So if I click OK, I'm going to get a scatter plot at the end of my output window, I hope. Thinking. Okay, there it is. Didn't have a lot of data here. Because, again, the N is unrealistically small to be meaningful, but it still serves as a good illustration. If I want the line of regression, whoops. Well, if I want the line of regression, I shouldn't have gotten rid of the output window. Do you have motor skill problems like I do when you point to the wrong thing, click on the wrong thing all the time? I'm closing a window I didn't want to close and I have to go back and reproduce it again, like this one. At least the things are in the right places. Okay. All right. If I double click, oops, don't want that, and I have an option that says Elements, and I want to show Fit Line. I think it's Fit Line at Total. Is that it? Yep. And there's my line of regression. So my predicting line would be that. So if I had what is it we're supposed to predict? We're supposed to predict 2 and 5. Well, if I were predicting 4, I would go to 4 and see where it is on the line, and go over. I would expect about 3 cars. That's how we would predict. But you don't want to do that visually, because it's too messy and things are too close together. Most of the time here it's fairly clear cut, but generally we want to do it mathematically, not visually. So let's go back to my output window, which I'm going to have to get again. But that's okay. No, because nope, I don't think so. Because I think I mistakenly closed that a minute ago. So no big. I've got to do it again. Analyze, regression, linear. Everything should be in the same place, and it is. So now you see my output window's got to be after my scatter plot. That's fine. So there's my scatter plot. That's what I had to do for A. For the last part, my equation is going to be, to make the actual prediction, I'm going to have to say that the number of cars, the expected number of cars, where have you heard that word expected before? The expected number of cars is going to be 0.558 times the number of drivers plus 0.692. So those are those two numbers right there in the equation. It's better not to round until the very end. Anytime you're in the middle of any kind of math problem, if you round, that will increase the round-off error. So you'll get a more accurate answer if you don't. And keep them, even these numbers are rounded to 3 decimals. They probably go out forever. They may be irrational numbers. I don't know. Yeah, y equal 0.558 times x plus 0.692. That's the old y equals mx plus b, which is, and we said cars are y and drivers are x. When we specified the scatter plot, that's what we called them anyway. So yeah, that's okay, because I'm trying to figure out what happens if we've got 2 drivers. Well, for 2 drivers, the number of cars would be equal to, or your y would be equal to 0.558 times 2 plus 0.692, which is going to be, and again, let me get on my slide rule to say that again. 0.558 times 2, whatever that is, plus 0.692, and I'm going to say this is going to be 1.808. Now, if you actually have to have you don't have 1.8 cars. I had a couple cars that were probably less than 1 time or 2, but you know, so we're going to expect about 2 cars. But now, if I had rounded off earlier, I might have gotten the number below, say, 1.5, which would have kind of led me to round the other way at the end. So on average, if you take a bunch of people with 2 drivers, on average the number of cars they would have would be 1.8. But for any individual specific household that had 2 drivers, okay, you got to call that 2. If I want to predict for 5, all I do, change a few names to protect the innocent. Instead of 2, I'm going to put 5 in there. Well, if I can find my calculator again, there it is. So 0.558 times 5, whatever that is, plus 0.692 is going to give me 3.482. So we'd expect about as close to 3 cars. If we had to make a prediction for an individual family of 5. If you had a bunch of families of 5, they'd probably average about 3.48 cars, about 3.5. So that's what I meant about how you plug a number in, an input, to produce or to predict an output. So the output's the dependent variable, the input is the independent variable. They kind of go together letter-wise on that. Other thoughts, questions about this simple regression example? There's nothing else. There's nothing different to click on. If you click on all those other options that we need for multiple regression, for example, if I did this, if I'm going to analyze it this way, and I'm going to go to get rid of all that stuff again, regression, linear. If I go here and click all these things, it doesn't matter because I'm still going to get my same correlations at the end, so you just get extra junk. I've still got the same numbers here that you go into the equation. So it's not wrong to get extra information. You just don't have anything to do with it in this example anyway. Questions? Can we write this up? Well, because I happen to be in an overly charitable mood, normally, let me deal with that in a minute. Generally, the standard assignment is a multiple regression write-up. I'll come back to that after I do the next homework example, if that's okay. Okay. Okay, the other homework example, the homework 3, which is based on lesson 33, exercise 2. I'm sorry, lesson 34, exercise 2. Thought I had that. Is that this one? With the relapse that we were talking about a second ago? Yeah, okay. All right, so that comes up on page 34, exercise 2, page 298 and 299. Now, they asked us to do a little extra here that we saw in one of the first examples, or one of the examples for, I think it was simple the way, yeah, that we did in the first simple one. This says that we've got the number of relapses. That's still okay. This can be your write-up because I'm not going to give you the write-up example of it. So yeah, you can write this up. Yeah. I'm just going to do the analysis. Yes, you can do that. You can do that as your APA write-up example because I'm not going to write it up for you. So yes. Okay. All right. Now I've got 1, 2, 3, 4. I've got 5 independent variables, but that's not the way it asks us the question. What does it do to ask us the question? I have 2 different kinds of these independent variables. So it says that with respect to their psychological state, or in particular on depression, psychological state, particularly on depression, propensity for substance abuse, and daily life stress. So I want an overall psychological state variable. So I'm going to have to combine 3 things into one. So I want to see what the psychological measures are. So I'm going to go to transfer, compute variable, and I'm going to call this psychological state. Is that what they said? Yeah, okay. Psychological state. Again, keep in mind, if you try to put a space in there, it'll yell at you. And I'm just going to simply add up the 3 things that go into that are the depression plus the propensity for substance abuse, they just call it SUBST, plus the amount of daily stress, they just call that stress. So my psychological state is going to be the combination of those things, and that's going to be another column. Now let me add an aside here. If you're doing like Likert scale stuff and you got a bunch of different individual indices to measure something, what I will do in this case a lot of times is I will not just add them together, but I'll get an average. So I might say, for example, these things in parentheses divided by 3. You can do that if they're on the same scale. These numbers are not on all the same scale. You can tell how different the numbers are. But like if you've got 1 to 5 numbers for everything, I just get an average that's also going to be a 1 to 5 number rather than a bunch of 3s added together. Just added information for a different situation. But for right now, I'm just going to add them all together. So I'm going to say OK. And as soon as I say OK, my computer's going to freeze on me and not do it. Yes, my computer's frozen as well. Okay, somebody hum the Jeopardy thing. Come on. It's not letting me do anything. Rats. All right, try it again. Okay, we'll start it again. Good thing we haven't done much. Okay, here we go. Transform, compute variable. Hey, this is what happens. Psychological state. Spell it correctly. Spell some of the words right. Starts with a P, not an S. Yeah. Clinical judgment for depression plus substance abuse plus stress. Click OK. Now when I click OK and I close my output window that I don't want, I'm going to get a column that says that. Wonder why it's so large. Don't know, don't care. But I'll make it, because the title's so long. Okay. And the other thing I'm going to do is, what's the other one it wanted me to get? Social support. Okay, so social support I'm going to have to compute. And it's going to give me where I left off. But social support. And that's going to be, not these things, that's going to be amount of social support and perception of social support. So I'm going to add those two together. And that should give me another column. Please work this time. And I believe it's going to, he says optimistically, yes. So I've got measures of psychological state and social support. Those are my two predictors. But since it's more than one, that's still multiple regression. So my multiple regression analysis is going to be found by going to analyze, regression. Again, it's still linear. My output, the dependent, is going to be the number of relapses. And my independents are going to be psychological state and social support. Again, those were the other smaller variables combined. So far, so good? Yes, if I didn't answer this, yes, you can write this up. This is a good one to write up. But I'll go back and deal with your other question earlier. Okay, so I'm going to go to statistics. In addition to what's defaulted to it, I'm doing this pretty quickly if that's okay, because we've just seen a bunch of them, but I'll slow down if you want me to. Select confidence intervals, R-squared, descriptives, and part and partial correlations. Continue, and OK, and we get an output window. So we get all kinds of stuff in our output window. To write the equation, we're going to use these numbers. Last column, the unstandardized coefficients. I hear bad words already. Somebody did something wrong. Okay. Hey, which is a better predictor, psychological or social support? Let's scroll over here. And look at my significance. Hey, they're both pretty good. But which was the bottom one? Social support's a little better, a little more significant. Contributions set, contribution psychological. I think we've answered everything they're asking for. If you want to do the write-up for this, for your APA write-up, this is probably the best one to do because we don't have a lot of these examples. Any question about either of the homework problems now? Okay.